doing
Good.
today?
How are you?
Good. All right, today we're going to be learning about stars. And I brought us a fun book to read called Inside Stars. But first, I'm going to tell you about the activity we're doing with the book. This is called a KWL chart. Does anyone know what KWL stands for?
Koalas want love.
That would be very cute, but it's not what that stands for. It stands for what we want to know about the topic, it stands for what we know about the topic, what we want to know about the topic, and what we learned about the topic. We're going to start by filling in what we know and what we want to know, and then after we read the book, we're going to fill in what we learned. So you better pay attention. So I'm going to give everyone one of these worksheets, and I'm going to work it with you on the board. Okay? There's one for you. All right. So, as I said before, this is called Inside Stars. So what do we know about stars?
Stars be old.
They're old. Okay, I need everyone to pay attention at the front, right as I write. They're old.
Right.
Bright.
Far away.
Far away. What else?
My mommy says angels are stars that look down on us.
That's cute. What else do we know? What do we know?
I know that.
Okay. Angels. What else?
That's
Do we know any types of stars or any names of certain stars?
The Little Dipper.
That's a constellation, but we'll put that.
Constellations?
Does anyone know any names of stars?
No. No.
Okay. What do we want to learn about stars?
The names.
What else?
Their color.
Color. Okay. Anything else?
No.
Do you want to learn about
No.
where they came from?
God.
Do you want to learn about how many there are?
No.
Let's put how many there are. Anything else?
No.
Okay, well let's get into the reading.
Okay.
This is called Inside Stars, and it was written by Andra Serlin Abramson and Mordecai Mark Maclow. We're only going to read a couple chapters today because we're going to break this down into smaller sections to fully learn about stars. So we're going to start out with the night sky. On the next clear night when it gets dark, take a look up in the sky. There are lots of things up there. You might see airplanes, satellites, and planets, but mostly what you'll see are stars. People have been wondering about stars for thousands of years. Today, we know a lot about them. Join us as we go inside stars and discover what makes them important to us. Yes.
I like looking at the stars at night, too.
Yeah, me too. It's really pretty. All right, and then, so on this page, it says only 5 to 10,000, or only 5 to 10 of the brightest stars can usually be seen from big cities, while thousands of stars can be seen when looking up into the night sky. There's only thousands you can see, but there's actually billions and billions of stars. Yes.
How many is a billion?
It's a lot. Okay, we'll talk about that later.
Okay.
Now, as we open up this book, we'll talk about what's out there. With so many different objects out in space, how can you tell what you're seeing? A telescope makes it easier for you to get a good look at faraway things. But even without a telescope, you can probably figure out what you're seeing in the sky. If a bright light is moving or blinking, it's most likely an airplane or satellite. If a bright light is moving or blinking, it is most likely an airplane or satellite. Sorry, I just said that. Planets like Venus, Mars, or Jupiter look like steady pinpoints in the sky. Stars, on the other hand, seem to twinkle and flicker.
My mom says she sees shooting stars and that they move and or blink like an airplane.
Well, if they're blinking like an airplane, they'll glimmer, like a star will glimmer. We'll talk about that. We'll get there. Good point.
Thanks.
Okay.
My mom says I'm really bright for my age.
Yeah. Okay. So, our home, the Earth, is a planet. It orbits the sun, which is a star. How many of you knew that the sun was a star? Did you know that?
Yes, and also my home is not Earth. My home is on Lingford.
Okay. 7 other planets also orbit our sun: Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. Along with at least 3 dwarf planets. We're not gonna go into that joke. That is immature.
Nobody said it but you.
Hundreds of planets have been discovered orbiting stars other than our sun. Now, the definition of stars is balls of hot gas that shine from their own energy. Can anyone repeat to me what I just said?
Balls of hot gas that shine from their energy.
Yeah.
Uranus.
Good job. Okay, we're going to be good and mature during this lesson. Planets are round objects in space that orbit or travel around a star, shine from reflected starlight, and are much larger than anything else in their orbit. And moons are natural objects in space that orbit planets and shine by reflected light. Constellations, like you talked about, the Little Dipper. That's
Big
a
Dipper.
constellation. And
Big
the Big
Dipper,
Dipper is
too.
also one.
Yeah.
Long ago, people looked up in the sky and noticed patterns in the stars. These patterns are called constellations. People in many cultures have made up stories to go along with the constellations and have given them names. To the ancient Greeks, for example, some patterns look like animals, such as the constellation known as Taurus the bull. Others look like people, such as Orion the hunter. During the summer months in the northern hemisphere, if you look up, you might see the summer triangle in the southern sky, connecting the brightest stars in the constellation: Lyra, the Lyra, Cygnus, the swan, and Aquila, the eagle. Thousands of years ago, astronomers noticed that the position of the lights in the sky seemed to change as the seasons changed. Back then, people believed that the sun and the other stars revolved around the earth. Today, we know that the earth actually revolves around the sun. As the earth moves around the sun, different constellations can be seen in the night sky at different times of the year. This is because the part of the sky that we see at night changes as the earth's position in relation to the sun changes. And back to the satellites. This is a picture of a satellite, and there are thousands of them orbiting the earth. And this one is very common. A lot of these are very common in Earth's orbit. Without them, global positioning systems, cell phones, satellite TV, and other devices would not work. How many of you use those every day? Yeah?
My mom thinks that the moon's a hologram.
Okay. Well, the question was, do you use a cell phone, TV, or other device every day?
Yes.
Yes?
Yes.
So without these satellites orbiting the Earth, you wouldn't be able to do that stuff
Or
every
Wi-Fi.
day. Yeah. Next, we're going to talk about the importance of stars. The next time you step outside on a sunny day, feel the heat of the sun, our closest star, on your face. Think about how important that heat is to us here on Earth. Save your questions until the end, please. Without that heat, our planet would be frozen solid. The Earth is at a distance from the sun that allows it to support life. If the Earth was farther away, it would be too cold and wouldn't be able to support life. And if it was closer, it would be too hot. The distance from the Earth to the sun is about, does anyone want to take a guess? Yes.
5 feet.
Not quite. Go a little bit into the millions.
1738 million.
Nope, it's about 93 million miles. If you think of the Earth rotating as a spinning top, the Earth's axis is actually tipped slightly to one side. As the Earth travels around the sun, its tilt does not change. The place on Earth where the sun shines the longest each day changes and from above to below the equator. The sun and the weather. Does anyone know anything about the weather and the sun?
My mom makes me wear sunscreen, but she doesn't make my brother because he's a big boy.
Okay, that didn't have anything to do with the weather.
The sun.
Okay. We're going to try and stay on task, okay?
The sun hurts if you don't wear sunscreen.
It does. It's because of the UV rays.
And sometimes it's windy and the wind hurts too.
Yes. Okay.
Yes.
The sun, correlating to the weather, the sun heats the oceans, causing water to evaporate into the air. Water vapor condenses from the warm air as it rises, forming the clouds made up of water droplets. As the clouds form, the condensation of the water heats the air, raising its pressure. Winds blow from regions of higher pressure to regions of lower pressure, carrying clouds along. When the clouds can't hold the moisture any longer, they release it in the form of rain or snow, or also known as precipitation, depending on the temperature. This process is also the source of all our fresh water, including snowmelt, runoff from mountains, and rain. The sun is our closest star, but it isn't the only one that's important to us. Earlier generations of stars, going back to the very first ones, produced all the elements in the periodic table other than hydrogen and helium. Now, here are some more vocab words. Condensation, the change from a vapor or gas to a liquid. Evaporation, the change from a liquid to a vapor or gas. And then lastly for today, we're going to learn about how scientists study the stars. Does anyone have any idea of what the scientists use to study the stars?
Telescopes.
Good job! Since the sun is too bright to look at directly, the sun and other stars are too dim that only their positions and colors can be measured with the naked eye, scientists have had to find other ways to study the stars. The invention of the telescope about 400 years ago was a big step forward for astronomers. It allowed them to discover stars and planets never seen before. Ever since then, people have been improving on the design. The very first astronomical telescopes magnified an image only 8 times more than what you can see with your eyes, much like a pair of modern binoculars. Today, telescopes can grasp light from stars billions of light years away. Does anyone know how long a light year is?
69 million years.
So a light year isn't going to be measured in years. It's a distance.
458.
458 what?
Steps.
Okay. A light year is the distance that light travels in 1 year, which is 6 trillion miles.
Dang.
Yeah. We can also use light minutes, which in light hours. Light minutes is 11 million miles, and light hours are 700 million miles. Light minutes and light hours are sometimes used to measure distances within our solar system. The sun is 8 light minutes away, while Neptune is 4 light hours from Earth. You guys are still paying attention, right? Because we're going to have to fill in what you learned at the end, right? Say yes, ma'am.
Yes, ma'am.
Okay. When astronomers study the stars, they are looking at light from the past. This is because the stars in most distant galaxies are so far away that save your questions till the end, please.
It's about right now.
After I'm finished reading.
need to
It's
know.
very rude to interrupt your teacher. Hand down. This is because stars in the most distant galaxies are so far away that it takes the light that they give off millions or even billions of years to reach us here on Earth. So the light that we see when we observe distant galaxies through a telescope is actually from a long time ago. The stars that emitted that light may have already exploded or evolved in some other way. This is a picture of a telescope that we talked about a few minutes ago. And there are different types of telescopes. Scientists use a bunch of different types, and there are different telescopes do different things. And so they're used to view all wavelengths of light emitted from stars, from radio to visible to X-ray. The mirrors of the largest optical telescopes, which we can see the faintest objects now exceed 30 feet in diameter, while the antenna of the largest radio telescope is more than half a mile across.
Wow.
Did you hear that?
Yeah.
Half a mile.
Big
All
boy.
right. This enormous 33-foot mirror of the Keck telescope In Hawaii allows observation of stars and galaxies that are billions of light years away. And then this is an example of a radio telescope. And then this is an example of an infrared, ultraviolet, and X-ray, or how it measures ultraviolet, infrared, and X-ray lights. All right, now that is all we're going to talk about for today in those chapters. Now, what have we learned?
It takes millions of years to see stars. Light.
Yes, we're really looking at stars from the past. What else did we learn?
Telescopes, see stars. The sun is also a star.
Good job. What were you saying about telescopes?
They see the stars for us, or help us.
Yes. What else? Is there something funny? What else did we learn? No, we're not going there. What else did we learn?
I don't know.
Did we learn about how long a light year is? Do you remember?
What?
Do you remember how long a light year is?
1738 million years?
No. Do we want to go back?
93 million? 93 kilometers?
A light year is the distance that light travels in 1 year, which is 6 trillion miles. Okay, and then tomorrow we're going to learn more about stars, and we're going to finish up this book with the other chapters. So good job for today. Keep this worksheet. We'll do the other half tomorrow, and we'll continue this. Good job, students.